Section 1.3, Objective, to understand and apply the basic terms of geometry. Our first term, point. A point is a location represented by a dot with no size or dimension or thickness. In geometry, to represent a point, we draw it like a period. We have to label this with a capital letter, any capital letter. Here, I will call it A. So this diagram represents what we call in geometry point A. The next term, line. A line is a series of points that extend with no end in opposite directions. To represent a line in geometry, we create the line that has an arrow on both ends, and that represents that it extends in both directions without end. There are a couple of ways that we can identify a line. First, we can have it labeled by points on the line. Here, again, I know that points are capital letters, so I've represented point A, point B, and point C. I can label this line or identify it by calling this line AC, but putting a symbol on top to represent that this is line AC. I could also call this line AB. I can continue by calling this line BA. And finally, I could call this CA. I'm allowed to do this because, again, this is a series of points that extend in opposite directions. So no matter which point I start with or end with, I'm going to talk about all the points on this line that are contained within this system that I've represented down below. Another way to identify a line is by a single letter, but that single letter would have to be a lowercase letter. So in this situation, I could also call this line N. So I have multiple ways of identifying figures in geometry. In this case, a line can be represented in many different ways, depending on the number of points or if it's represented by a lowercase letter. Our next term, plane. A plane is a flat surface that has no thickness, but extends with no end in the direction of the lines that define the plane. In geometry, we usually represent this by a four-sided figure. It can be a three-sided or five-sided figure or multiple sides. And we also label this a capital letter. So this would be known as plane M. Or what we could also do is identify a plane by its points. For example, if I created this triangle, and again, points are represented with capital letters, I could call this plane A, B, C. Or again, I could rearrange the letters and it would still represent the same plane, BCA. And I could rearrange these figures till I exhaust all the options. But I think you get the idea that I can name this figure in any rotation of my letters. Another example of representing my first plane would be if I identified points on the plane or in the plane. And I could also call this plane M, of course, as we first identified. It is not a point on the plane, it is just the name of the figure. Or I could identify it by the points, which would be plane A, B, C, D. Again, I could start with any letter, but once I pick a letter, I need to either go clockwise or counterclockwise if I'm going to identify it by every point on the plane. I also could shorten the name of the plane by identifying just 3 points, because we need 3 points to create a plane, 2 points to create a line. So here I could go A, D, B. That way, This represents the plane. Again, I didn't cross over because I didn't name C as the last point. And I could have multiple ways of naming this with 3 letters. I'll give you one more example. Here I could have named D, C, B. In each case, each one of these representations is identifying plane M. Space. The definition of space is the set of all points. Therefore, space contains an infinite number of planes. Therefore, it would contain an infinite number of points and also lines. An example of that is if you take a look at the sky at night, you see multitudes of stars. That would be known as space. Collinear. Collinear means that points that lie on or in the same line. Let's take a look at an example. In the diagram, I have 3 lines. Line AE, or again, we could name this multitudes of ways. For example, line AF. Or I also have line L, which is the same 2 lines I already named. We also have line DC, and we also have line HG. Now, what we want to do is identify and answer some questions based on the diagram. The first question is to find all points collinear to A. So all points that are collinear to point A or with point A are point B, point E, point F, and L is the name of the line. Therefore, that is not a point. Next question. Collinear to point C. We want to name all points collinear to point C. Here we could say point B and point D. And finally the question, collinear to point G. All points collinear to point G would be point H and point F. The next term we'd like to look at is coplanar. Coplanar points are points that lie on the same plane. Let's take a look at an example. In this diagram, I'm given 2 planes. One is highlighted a little darker shade than the other. Remember, we can label these planes by their points. So the darker shaded plane has 3 points in it. Therefore, we could name this plane STW. The other one, RTS. And from my labeling, I think we've already asked the question, what points are coplanar? Well, W, T, and S are coplanar because they all lie in the same plane. R, S, and T are also coplanar because they lie in the same plane. S and T are in both planes because they are in both the gray plane and the clear plane. R and W are not coplanar. They do not lie in the same plane. Our next slide refers to postulate 1.1. A postulate is something that is assumed to be true without a proof. Later into geometry, we will talk about proofs. But here, postulate 1.1 states that through any 2 points, there is only one line. Therefore, we've already defined earlier that a line must consist of 2 points, and we can label this either way, line AB or line BA, or we could label it with a lowercase letter called line T. But we must have 2 points to create one and only one line. Postulate 1.2 states that if 2 lines intersect, their intersection is at one and only one point. Here we're given 2 lines, line BC, line AD, and their point of intersection is point E. Therefore, E is collinear to both AD and BC. But point B and A are not collinear because they do not lie on the same line, nor do C and D. Our next postulate states that if 2 planes intersect, their intersection is at one and only one line. Here, as in the previous diagram, we are given two planes. We have the darker shaded gray one and the clear one. Plane STW is the gray shade plane, and RST is the second plane. They intersect, and their intersection is line ST. Our next postulate states, through any three non-collinear points, there is one and only one plane. Here I'm giving 3 points. They form a triangle, and I can identify the plane to be A, B, C. Now remember that this plane can extend forever without end. In other words, it would keep containing the entire screen and continue on. Next, words and phrases that mean the same thing. Whether a point is on the line, whether a point is in the line, contained in the line, or the point lies in the line, or the point lies on the line, or it is part of the line. These statements mean and ask the same questions for every situation. Let's look at an example that refer back to the previous terms and postulates. Number 1, how many planes appear in the figure? Here we have 3 planes. We have the rectangular one, which is in green, the one that is labeled N, that is in gold, and the front one, which is labeled M. So here we have 3 planes. Number 2, line FG and line AB intersect at which point? Line FG is actually going through the green plane. The green plane is like a sheet of paper that is laying on the desk. So it is actually not contained in the plane, it goes through it. Here, AB is contained in the plane. But remember, from a previous postulate, 2 lines intersect at one point. Their point of intersection is point D. Number 3, which lines lie in plane P? Remember, plane P would be like a sheet of paper lying on your desk. The lines that are in plane P are lines AB and line CD. And recall that I could label these lines a couple of different ways. I called this C and D. I also could have called it EC, and there are other ways. Number 4, which points are coplanar with point A? Recall that coplanar means points that all lie in the same plane. Therefore, point A is in plane P. Therefore, I need to have all points that are in plane P. Points in plane P are C, E, B. Point F and G are not coplanar with A. If we refer to point P being on the surface of a desk, then this line FG is actually going through the desktop. In other words, point F would be above that sheet of paper or the desktop, and point G would be below the surface of the paper or the desktop. Number 5, name the intersection of planes N and M. From a previous postulate, we know that 2 planes intersect and their intersection is a line. N and M are the gold and yellow planes. They are sitting on top of plane P, and this represents basically a book that is opened up on plane P, but it's standing on its edge, it's not lying on its back. Therefore, the line that is formed by these 2 planes is line FG. Now, it doesn't look that like FG is contained into 2 lines because it extends through, but recall, planes extend forever in all directions. So these 2 planes would contain both F and G. So the intersection of the 2 planes would be line FG. 6, name a point that is collinear with points F and G. Recall, collinear has a definition of all points contained on the same line. What point is also contained on the line of F and G? That would be point D. 7. Line AB is the intersection of which planes? Two planes intersect to form a line. Therefore, the two planes that intersect to form line AB would be plane N and P. 8. Point F lies in which plane or planes? Point F would be contained in two planes. Since it is part of the line of the two intersections of plane N and M, therefore F is in N and M. 9. Name the intersection of planes M and P. Two planes intersect to form a line. Therefore, the intersection of those two planes is line CE. 10. What is another name for line AB? Line AB can be named several different ways. The first one I could say is line AD. Line BA or BD. Also, DB could be another name. Another example, name the 5 visible planes of the pyramid. We could have the base of the pyramid, which would be plane VWXY. Then the sides of the triangle, which are 4 separate triangles. Therefore, plane VWZ, plane WXZ, plane ZYX, and finally plane VYZ. Next, name 2 planes that are not drawn in the diagram. What we could find is a plane that could connect W, Z, Y, and also V, X, Z. Next, name 4 lines that contain point Z. That would be line VZ, WZ, XZ, and YZ. Name the lines that intersect at point V. WV, YV, name the intersection of line VY and XY. Here, I could go to the diagram and see the intersection by VY and XY, or I could take a look at just the symbols and know that 2 lines intersect at the point, and the point given here is point Y. Next, name the intersection of planes VYZ and XZY. From a postulate, we know that 2 planes intersect and their intersection must be aligned. Here, the common points involved between the two intersection of the planes is YZ. Our next example has a diagram of a cube. Our first question, name the intersection of plane FBC. FBCG is the right side of the cube, and plane HDG. HDG or HDCG is the back side of the cube. Recall that intersecting two planes means they must form a line. Here, the line of intersection for the two planes is GC. Name the intersection of plane HGE. Problem 2. Name the intersection of plane HGE plane GCB and plane EAB. Here, we have three planes intersecting. We know that two planes intersect to form a line. The front plane and the right plane form FB. The top plane and the right plane form FG. And the top plane and the front plane form line EF. These three planes have in common of intersection is point F. How many planes are visible in the diagram? We have, going from counterclockwise, 4 visible planes. Then we have a top and a bottom. That would give us 6 planes. Our last question. Name 2 planes in the figure that are not drawn. Our first one would be back to front, which would be plane HDB. Or also HDBF, and then from left to right, which would be plane EAC. Also labeled EACG.